Welcome to my YouTube channel. Before we start the session, subscribe the channel and click the bell button to get more videos. Today we are going to study about the sensors and their applications. Before we start the session, I would like to give a quick overview that what we are going to study today. Introduction to sensors, the usefulness and key purposes, types of sensors, and finally the industrial usages. Imagine a world where machines could sense their surroundings just like humans do. Sensors exist because of automation in industries. When humans couldn't handle everything themselves, automation came to the rescue. We realized we could create devices to mimic our senses. Just like our eyes, ears, nose, skin and tongue. They collect data from the environment and send it to our brain. Sensors do the same for technology. They gather information and send it to a central system. The goal: use non-electric data to guide process. Here you can find sense organs, what is sensitive to and what they can sense. Okay, let's dive deeper into how sensors actually work. We have already saw how they were inspired by our human senses. Now here is the scoop. What is a sensor? A sensor is like a translator between the physical world and our machines. It takes things like temperature, pressure or flow rates and turns them into something our devices can understand. Imagine it's like a bridge connecting the real world to the digital world. Then how it works? When a sensor sends something like heat, pressure or flow rate, it converts that information into an electrical signal. This signal can be either current or a voltage. So in a nutshell, sensors help us communicate with the environment using electricity. In this table, you will find different sensor types categorized based on their detecting properties. These properties correspond to the physical quantities we discussed earlier. The magic happens when these properties are transformed into electrical signals. Let's delve into the fascinating world of transducers. What is a transducer? A transducer is like a backstage hero in the world of sensors. When a sensor teams up with signal conditioning, think of it as a power-up, it transforms into a transducer, whether it's electrical signal or not. Their primary job is to shape different energy forms. Sensors versus transducers. Remember, all the sensors are transducers, but all the transducers are not sensors. Sensors rely on transducers to perform their magic. Together, they bridge the gap between the real world and our digital systems, making our technology more responsive and connected. Here, when you are studying about the sensors, you should know about the transmitters. A transmitter converts the raw output signal from a sensor into a standardized instrumentation signal. The transmitter ensures that sensors' information can be understood and utilized by other devices in the system. Usually, the transmitters can convert into 24 voltage DC or 20 milliamperes. It is a standard value. In our previous discussion, we explored the basic operations of sensors by comparing them to our human sensors, just like our skin sends temperature and sends signals to our brain. Sensors collect data from the environment and transmit it for further processing. Now let's focus on actuators, the counterparts to sensors. What are actuators? Think of actuators as the output side of the system. They take processed information from the sensor and perform actions based on the data. Imagine an industrial scenario. You need to monitor the temperature of a liquid and control accordingly. Here, how it works. The temperature sensor acts as our skin in this setup, detects the temperature of the liquid and converts into an electrical signal. Just like our skin sends temperature data to the brain, the sensor sends its output to the control system. Control system processes the sensor's data. It's like our brain analyzing the temperature information. Based on the input from the sensor, the control system decides what action to take. The actuator is our industrial muscle. It receives instructions from the control system. In our example, the actuator controls a flow control valve connected to the furnace. If the liquid temperature is too high, the control system signals the actuator to adjust the valve, regulating the heat output from the furnace. So just as our brain tells us to move our hand away from fire, the actuator responds to the sensors input by adjusting the flow control valve. Together, sensors and actuators create a dynamic feedback loop, ensuring effective and precise control in various applications. Here you can find some usefulness and key purposes: process monitoring, experimental modeling, product testing and qualification, product quality assessment, fault prediction, detection and diagnosis, warning generation and surveillance. Also, when we are talking about industrial usages of sensors and actuators, SE is a very popular thing. It helps us to reduce physical bias and components. Also, we can use less number of input and output cards for PLC. It's connected in masters and slave method. Usually, a master can connect with 64 slaves. Here, the sensors and actuators works as a slave. So, hope you understood everything. If you are struggling to understand some basic concepts in the engineering field, I am here to explain you. Don't forget to subscribe my channel and follow me on Facebook, and also you can find some notes regarding engineering and technology on my blog. Thanks for watching.